Okay, so this is 811 here, and we're given two scenarios here. One has this 45-degree angle that this person's pulling down upon, and this one, the person's uh, pulling perfectly horizontal here. And we know that the static coefficient of static friction between the person's feet and the ground is 0.6. We also know that the weight of the person, let's make sure the weight of the person is 200 pounds here. And what we're looking for is the maximum weight that a person can lift at a constant velocity. So this, with no acceleration, that means it's still a static problem here. So in both cases, we need to figure out the tension that's being pulled on the rope here, or the cable. And the pulley system is the same in both situations. All right. So let's just find the tension in these cables first off. And we'll do that by looking at pulley C. So pulley C has three cables attached to it, or the same cable attached in three places. So the tension pulling upward is 3T. And then the downward, we have the weight, which we're trying to find, this maximum weight. So if we just do the sum of the forces in the y direction here and set those equal to 0, we have positive 3T going upwards. We have W going downwards, setting those equal to 0. We find out the tension here is W over 3. So the tension in the cable is a third of the total weight here. All right, so let's move down here, and we'll first start analyzing the situation where they're pulling at a 45-degree angle. And I get to show off some of my great drawing skills. Hopefully this turns out all right. All right, so I have this person, and they're pulling on the cable here. And that's, we found the tension here is W over 3, and that's at 45 degrees here. We know that the person's weight downward is 200 pounds. And then we're also know that there should be a normal force on the ground pushing up on the person, and the friction here, the friction force, should be 0.6 times the normal force here in the horizontal direction. All right, and I drew that this way because it's obvious to see that if there's a force going this direction, the frictional force has to balance that, and it needs to be in the opposite direction. So let's solve this equation. We can first, or solve this problem. We can first start by taking the sum of the forces in the y direction, and we have this W over 3 pointed upwards, but it's just a component of that. That should be sine of 45 degrees. And next we have the downward of the weight of the person, 200. We have the normal force pushing positive straight up, and we set that equal to 0. We don't know W and we don't know N. This is an equation with two unknowns. We can't solve that yet. So let's do the sum of the forces in the X direction. And we have the tension here, which is acting in the negative direction. That should be cosine 45 degrees. And then we have the normal force in the positive direction, 0.6 times the normal force. All right, so with these two equations, this makes this solvable. I think the easy way to solve these two equations is add them together. So we'll take this value and add it to this value, and we know that adding the right-hand side should still be 0. So if you notice, if you remember, sine of 45 is the exact same thing as the cosine of 45 degrees. So adding these two together results in, they cancel each other out, so we get 0. And then we have 200 plus n plus 0.6. So we're just adding this side to these two together for the left-hand side, and then the right-hand side is 0. we come out with N equals 125 pounds. And then subbing back into one of these equations, we come out with W, which if we round it, it's 318 pounds. All right, so that's the first scenario. That's part A that we were looking for. And now we'll move on to part B, and we'll draw the free body diagram of the person again, right? And this time the person is pulling directly horizontal. The tension is still the same. So on the hands here, we still have a tension of W over 3. We have a normal force, which is going to be different than in the first case, as well as the frictional force, but it's still 0.6 times N. And we have the downward weight of the person of 200 pounds. Okay. So I guess we can start with the equilibrium equations. Sum of the forces in the y direction, set those equal to 0. We just have the weight of the person downward plus N equals 0. We just come up with that. So N is equal to 200 pounds. So that normal force is higher than what it was in point A, which also means the frictional force is going to be higher. So if we sum the forces in the y direction, or I'm sorry, the x direction now, we have W over 3, that's negative, plus 0.6 times N equals 0. We've already figured out N here, so we can plug that in and solve for W, and W comes out to be 360 pounds. So actually, this person is able to lift more with that additional pulley that allows the person just to pull horizontal.